Hello, children. Today we are talking about dilations. Now, a dilation, this is a transformation where a shape changes size. So it's dilation where a shape changes its size, and it can either grow or shrink. It can either get bigger or it can get smaller. So every time we have a dilation, we're looking, did this shape grow the same or did it grow differently? We want to grow the same shape each time. Okay? So the way that we can tell if the shape is grown is by comparing the ratios of the side lengths. So if I have these two dilations and I have, this is point A, B, C, this is A prime, B prime, C prime. Prime means the shape has changed. These little tallies here mean the shape has changed. So if I want to compare the relationship of side AB over side A prime, B prime, I would say side A, just so you know, I'm looking right now at Mrs. Hop and Mrs. Barnes dancing outside of the window as I'm creating this video. So just imagine that happening as you're watching this, just so you can have to deal with what I had to deal with. All right, they're gone now. Side AB is 3. Side A prime, B prime is 6. 3 over 6 simplifies to 1/2. That's one of my sides. Now, I want to compare side BC with side B prime, C prime. Side BC is 4. Side B prime, C prime is 8. That simplifies to 1/2. Since these are the same, this is a dilation. Okay, these are the same. Because my ratios are the same, this is a dilation. This is growing at the same rate. Okay, now, what I want to look for in a dilation is I want to look for something called the center of dilation. So I want, if you can hear that kid screaming, me too. Center of dilation. And how to find the center of dilation is to draw a line from point to point prime, and the intersecting point of all lines is center of dilation. Okay, that sounds very confusing. I'm going to explain to you what that means. So I'm going to draw a line here that goes through both of my A's. Draw a line that goes through both of my A's. I'm going to draw a line that goes through both of my B's. Draw a line that goes through both of my B's. I'm going to draw a line that goes through both of my C's. Draw a line that goes through both of my C's. And where those three lines meet, this right here would be my center of dilation. Okay, that's saying that from here, this point right here, it's extending out, 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 and dilating all of my points along that line. You don't really need to care about that a ton, but that exists in case you were curious. Now, let's say that I had these two shapes here. Let's do new shapes on my line. Let's say I have, we'll go with a rectangle like this. This is a 2 by 4, A, B, C, D. And then we'll do a rectangle that looks like this. This is a 4 by 6. We'll call this A prime, B prime, C prime, and D prime. So I'm going to say, is this a dilation? Is AB over A prime, B prime the same as AC over A prime, C prime? So let's check. AB is 2 over 4 equals 1/2. B prime is, AC is 4 over 6. That equals 2/3. Are 1/2 and 2/3 the same? No. So this is not a dilation. This is not a true dilation because these aren't the same. Okay, so that's how we can tell if something is a dilation. Now, if I wanted to dilate something, let's say I have a shape and I want to dilate it. I have this triangle here. I have this triangle here. This we'll call, let me see if it'll snap it into a real shape. There we go. This is A, B, C. And I want to dilate by 2. I want to have a dilation of 2. This we call our scale factor. The scale factor tells us how much the shape grows or shrinks. So if I wanted to dilate this shape by 2, what I want to do is I want to take each of my points. I want to take all my points of A, B, and C, and I want to multiply each of those things by 2. So point A is at the point 1, 1. Point B is at the point 2, 3. And point C is at the point 5, 1. I want to take each of those and I want to times all of my values by 2. I want to times 2 into everything. Distribute, right? We've talked about distributive property. Distribute my times 2 into everything. 2 times 1 is 2. 2 times 1 is 2. 2 times 2 is 4. 2 times 3 is 6. 2 times 5 is 10. 2 times 1 is 2. And so this right here gives me the coordinates of my 3 new points. I've got 2, 2, 4, 6, and 10, 2. And here is my new triangle of A prime, B prime, C prime. Okay? A prime, B prime, and C prime. That gives me my new shape. Okay? So if I said, I have the point, I'm just going to do a point and have you dilate one point for me. I have the point 3, 9. 3, 9. And I want to dilate this point by a scale factor of 2/3. I want to times each of those numbers by 2/3. I would take my 3 and I would say 3 times 2/3, 3 over 1. And I would take my 9 and say 9 over 1 times 2 over 3. Remember, every time we're multiplying by a fraction, put it over 1. Multiply straight across. 3 times 2 is 6. 1 times 3 is 3. 6 over 3 becomes 2. That's going to be my new x value. 9 times 2 is 18. 1 times 3 is 3. 18 divided by 3 is 6. That's going to be my new y value. And my dilation is at the point 2, 6. This is A. This is A prime. That's my new point when I dilate. All right? So what I want you to do is I want you to let me know what would my point be if I started here at point A. What would A prime be with a scale factor of 3/4? A prime equals what? All right, good luck. Let me know if you have any questions. Have a great day.